you need to do is when you open it up, you'll get to this link, and every time someone opens it up, it's going to generate a different mass for the astronaut, and the force of the fire extinguisher is going to be different. So everybody that opens it up is going to have a different data set to work with. Anyways, the astronaut starts at 0 meters. They're at rest. So that means their starting momentum is 0. You're going to hit this activate button, and it's going to turn on the fire extinguisher, which is going to accelerate the astronaut. Now, for this lab, you want to, after you hit activate, you're going to hit stop. And what you want to do is you want to stop it somewhere close to where 5 meters is, so that little kind of light line in between 0 and 10 for the first trial. And then when you reset, you're going to repeat, but then you're going to try to stop it near 10, then stop it near 15, stop it near 20, and so on. You do not have to have the astronaut get exactly on the line, just get it really close. So let me kind of show you what's going on here. So I hit activate, I see him moving. All right, he got really close. So there you go. Now you let him keep going, and he's going to pass through these 2 red lines, which is a photo gate. That's going to time how long it takes for him to go through the photo gate. Now, the distance between the photo gates is 10 meters, and it tells you it took 1,780 milliseconds to pass through the photo gate. One of the things you're going to have to do is convert that to seconds, which is there's 1,000 milliseconds in a second. So this would be 1.78 seconds. The other thing that you need, the other piece of data that you need for this lab is you need to know the fire time. So this clock down here times how long the fire extinguisher was on for. So this goes up has divisions of 0.1. So that would be like 1.1, 1.5. This is close to being exactly on the 2, but it's a little over. So I would say like maybe this is 2. It's not on the 2.1. Maybe I would call this 2.02 seconds. So you want to try to be accurate with your measurement of this. If you need to, you can enlarge your screen to get a bit better look at it. Okay, so that was the first trial. You hit reset, activate again, wait till it gets towards the 10, stop, and we should get a smaller time to get through the photo gate because the force was acting longer, accelerated him faster, and so on. So there you see 1.3 is a faster time to get through the photo gate, and the fire time is greater. This one, I would say, as an example, this is 2.56. I would call this one 2.7. Right? I think that would be good. All right, so you have to repeat that a bunch of times until you get all the way up to 60, okay? 60 meters for the fire time to be on for. When you've collected all that data, you're going to have to graph it. And let me just show you before we do that. So at the bottom here of the sim, when you hit finished, it's going to ask you to make a graph, use the graph equation to calculate the momentum created if the fire extinguisher was on for 17 seconds and the speed if it was on for 17 seconds. So you're going to have to make a graph, and I'm going to show you the graph you're going to make and all that stuff in just a second. But when you enter all this information in, you have to hit submit and get the correct answers. If you don't get the correct answers, you're going to have to start all over, which means you're going to get a new astronaut, new data set, and everything. So make sure you pay attention to all the little details the first time so you don't have to start the lab all over. You're going to have and what you need to fill in. So this part right here, let me just highlight it because it needs to be blue. All right, just to kind of point out a few things. So any of these cells that are blue, that's information, that measurements or data that you recorded from the sim. So like the mass of the astronaut, That's not going to change. So that's going to be the same right here for all your trials. The gate time, that does change, as we saw. When the fire time is less, the gate time will be longer. Over here, you're gonna put it in milliseconds, and then in here, you have to convert it from milliseconds to seconds. So as an example, if it was 1,785 milliseconds, if you see a yellow cell, you have to enter a sheet formula. So I have to tell sheet, I'm going to do a formula, hit equals. And what I want to do is I want to take this value. So I'm just going to click this cell, divided by 1,000, hit enter. And then there's my information. And then when I'm ready, I just click that cell, bring the cursor to the bottom right until it turns into a plus sign, click and drag, and then it will repeat it for all the other ones. Okay. Fire time, that's a measurement that you have to take and then fill that in. And then momentum change. So the astronaut started with no momentum, okay? And then he went, by turning on the fire extinguisher, he ended up gaining some momentum. The speed that he goes through the gate, that speed is constant, right? And that's going to be his momentum change. So he started with 0, and then he ended up with some momentum to carry him through the gate. Now, momentum is mass times velocity. Well, the velocity he passes through the gate with is going to be the gate time and speed, right? Sorry, distance. So if it took him 1.785 seconds to travel 10 meters, what's his speed? You would do distance divided by time, and then distance divided by time times the mass of the astronaut will give him the momentum change. All right, so you should figure out a way to enter a single equation to do that. All right, again, in this cell right here, you're going to hit equals, and it's going to be 10 meters in 1.785 seconds times whatever the mass is of the astronaut, and that will tell you the momentum change. All right. Once you have all 12 trials, you're going to graph these two columns. So just highlight fire time and momentum change, and then insert chart. All right. You want a scatter plot. And then once you have that in there, you need to add a trend line, and then make sure you label, when you hit label, you use the equation. When you do that, you will get something that looks like this. All right. This equation is your slope equation. They don't write a y in front of it. They write what the y-axis is. So change in momentum, which is the y-axis, is equal to, in my case, 110 times x plus a negative 25.8. So this would be 110 times some x value minus 25.8. That would give me my change in momentum. The x is the time for the force, the fire time. Okay, so if I told you, figure out, like, this graph only goes up to 9 seconds. If I said, okay, well, what's the change in momentum if I had the fire extinguisher on for 20 seconds? Well, 20 seconds would be the x. You would do 20 times 110 minus 25.8, and then that answer would be your momentum change. Okay. Back to the sim. So when you hit finish, you're gonna have to put the slope in, which in that example I was just showing you would have been 110, right? And then the momentum change. So they're asking 17, so you'd have to do 17 times whatever your slope is, plus or minus whatever they tell you in the equation, and that would be your answer here. The last part, the speed created by that thrust, that 17 seconds of thrust. Well, speed is just momentum divided by mass. So you're going to take the momentum you got above right here and divide it by the mass of the astronaut to get the answer here. Once you do all that, you can hit submit.